So this video we're going to be doing some shortcuts on how to prove triangles are congruent. So for two triangle congruence by side, 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 and side angle side. So last class we said that if two triangles have three pairs of corresponding sides and three pairs of corresponding angles, they are congruent. So that means the three sides are equal, so they're congruent, and the three angles are congruent. Now we can learn some shortcuts so we don't have to prove all of the parts are congruent. So our first one is postulate 4-1, side, side, side postulate. If three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. Okay? And when we are labeling this, we label it in the order that it is given. So JK, and then we do L. So that means this is going to have to be X, Y, and then Z. So you have to do it in the same order that they are congruent in their pictures. Okay, side angle side. If two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the two triangles are congruent. Okay, so side angle side, that means I need a side, an angle in between my other side. So here's my side, my angle, my side, my side, my angle, my side. Okay, so they have to, the angle has to be sitting in between the two sides for you to prove that they're congruent. Again, the order of this labeling matters. Okay, so now let's do this proof. So I have DA is congruent to MA and AJ is congruent to AZ, okay? And that's given because we always start with our given statement, okay? So then my next spot, I'm trying to prove that this is true. So that means I want to see if one of the things I just learned are true. So my options are side, 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 angle, side, 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 angle, and angle, side, angle, okay? So we're trying to use one of those to prove that these two triangles are congruent. So we could say, because these are vertical lines, JAD and angle ZAM are congruent because they're vertical angles. So since we have side, angle, side, now, because we have our side, our angles, and side, we're able to prove that those two triangles are congruent. Again, the order matters on this. So by side, angle, side. Postulate 4-3, angle, side, angle. Okay, if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent. Okay, so this is just, we have our two angles, and then we have our side in the middle of them. Okay, and again, order matters. So if I'm going A, B, C, then that means I need to go D, E, F, okay, because D is congruent to A, that's why they're in the same spot. E is congruent to B, that's why they're in the same spot, and C is congruent to F. So they have to be in the correct order. Here's our next one, angle, angle, side. So if two angles in a non-included side of one triangle are congruent to two angles in the corresponding non-included side of another triangle, then the triangles are congruent. Okay, so we have our angle, angle, and side. So whenever we have that, they are congruent. Again, order matters. Since A is congruent to E, they go first. B is congruent to F, so they have to be in the same spot. And C is congruent to G, so they have to be in the same spot. So name the theorem or postulate that makes the triangles congruent. Okay, so it looks like we have a side, and an angle. So we have side, side, angle, congruent to side, side, angle. Okay, so my theorem then is going to be the side, side, angle theorem. Okay, this one, it looks like we have a side and an angle. So my options here are going to be either SAS, SSA, or I guess ASA, because we have to have at least a side. Okay, so if I have a side and an angle that are congruent, that means I either need another side to make it SAS, or I need another angle. Well, it looks like since they share, we could use the reflexive property, BC is congruent to BC, to get this to be congruent, since they share that same side. So now, side, angle, side is what proves that my triangles are congruent. So if I wanted to say my triangles are congruent, I could say triangle ABC is congruent to triangle DBC, okay, because A is the same spot as D, because their angles are congruent. B is in the same spot as B, and C is in the same spot as C. Okay, so when we're doing this one, we are trying to, it looks like we have two sides, so my options are side, side, angle, side, angle, side, 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 angle. Okay, so I need to use one of those to prove it true. So it looks like they share the length BD. So since they share it, we can use the reflexive property, because BD is congruent to BD, to get our third side to be congruent, because they share it. So, oh, we also had side, 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 sorry. So side, side, side then is going to be to prove it congruent. So I could say triangle ABD is congruent to triangle CBD. Okay, so this one, it looks like we have two angles that are congruent. So it either is, the only option that we actually have is angle, side, angle. So can we get a side to be congruent? It looks like they are sharing this side, so that means BD is reflexive to BD, so BD is congruent to BD. So by angle, side, angle, we can prove that they're congruent. So triangle ABD is congruent to triangle CBD. Okay, it looks like we have all three sides being congruent to all three sides. So this one's pretty easy. We got side, side, side. Okay, so I'm going to say triangle ABC is congruent. Now we got to do some matching up. So A is in between the 1 dash and the 2 dash. So 1 dash and 2 dash. So we got E. My B is in between my 2 dash and my 3 dash. So 2 dash and 3 dash. So F is next. And so then my C is going to be with the G.